There are some trigonometric identities that will help us evaluate integrals of sine and cosine with different arguments. Now, these identities are sine A cosine B is equal to 1/2 of sine A minus B plus sine of A plus B. The next one is sine A sine B equal to 1/2 cosine of A minus B minus cosine of A plus B. And thirdly, we have cosine of A cosine of B equal to 1/2 cosine of A minus B plus cosine of A plus B. Right? So with these formulas, we can evaluate integrals of the form sine 4x cosine 3x dx. There is no fundamental formula that will give us the integral of such kind of integrand. So here we are going to apply the first identity. Our A is 4x and B is 3x. So applying identity 1, we have 1/2 of the integral of sine of 4x minus 3x plus sine of 4x plus 3x quantity dx. This is equal to 1/2 of the integral of sine 4x minus 3x is x plus sine of 4x plus 3x, which is 7x, everything times dx. We then integrate term by term. We have 1/2. The integral of sine x is negative cosine x, and the integral of sine 7x dx is negative 1 over 7 cosine 7x plus c. We can factor the negative sign, thus we have negative 1/2 quantity cosine of x plus cosine of 7x plus c. We take on another example with the integral of sine x over 2 and sine of 2x dx. For this particular integral, we apply the second identity, which is 1/2 cosine of x over 2 minus 2x minus cosine of x over 2 plus 2x, everything dx. 1/2 the integral of 1/2 minus 2, that is equivalent to negative 3/2 x minus cosine of 1/2 plus 2 is 5/2 x quantity dx. Now cosine of negative 3/2 x is the same as cosine of positive 3/2 x. We know that the cosine of negative theta is equal to cosine of positive theta. Okay, so we now have here 1/2. the integral of cosine 3 halves x will be 2/3 sine of 3 halves x plus the integral of cosine 5 halves x is 2/5 of sine 5 halves x plus c. We can distribute 1/2. In that way, we'll be cancelling the 2's. So we have 1/3 sine of 3 halves x plus 1/5 sine 5 halves x, okay, plus c. Another example, say the integral of cosine of 5x sine of 3x and sine of x dx. Notice that in this integral, there are 3 functions involved: cosine 5x, sine 3x, and sine x. So we take 2 factors at a time. Let us consider sine 3x and sine x and apply the second identity. So that will be cosine of 5x times 1/2 sine 3x sine x is cosine of 3x minus x, which is 2x, minus cosine of 3x and x, which is 4x dx. Let us factor 1/2, and then we write cosine 5x cosine 2x dx minus the integral of cosine 5x cosine 4x dx. Okay, so in this case, what did we do? We factored 1/2 and then we distributed cosine 5x. So for the first integral, it will be 1/2. We apply here the third identity, which is cosine of 5x minus 2x is 3x plus cosine of 5x and 2x, which is 7x dx, minus 1/2. We're now on to the second integral, and we are applying the third identity. So 1/2 5x minus 4x is x plus 5x and 4x is 9x. So that will be cosine of 9x dx. So we can factor 1/2. And it joins with 1/2, which is now equal to 1/4. And we integrate each term, beginning with cosine 3x, which is 1/3 of sine 3x. Then for cosine 7x, that will be 1/7 sine of 7x minus the integral of cosine x is sine x and minus, okay, the integral of cosine 9x, which is 1/9 sine of 9x plus c. Okay, so let me write the final answer. 1/4 quantity. Let me rearrange this. Let me begin with negative sine x and then 1/3 of sine 3x plus 1 over 7 sine 7x, and finally negative 1 over 9 sine 9x plus c. So let us have one final example. The integral of sine squared 2x and cosine squared 3x dx. Alright, before we apply any of the identities given, we have the identity for sine squared and cosine squared. For sine squared, we know that that is equal to 1/2 1 minus cosine of 2x squared. 2x times 2 is 4x. You can still recall the identity used for case 2 involving powers of sine and cosine, where the exponents are positive even integer. And for cosine squared 3x, that will be 1/2 1 plus cosine of twice the angle 6x dx. So 1/2 times 1/2, that will be 1/4. And then we multiply these two. We'll be getting 1 minus cosine 4x plus cosine of 6x minus cosine of 4x cosine of 6x quantity dx. Continuing, we have 1/4. Then we can now integrate the first three terms. And what do we get? The integral of dx, of course, is x, minus the integral of cosine 4x is 1/4 sine of 4x of cosine 6x, that is 1 over 6 sine of 6x. For this integral, cosine 4x, cosine 6x, we apply the third identity, which is 1/2 cosine of 4x minus 6x is negative 2x plus cosine of 4x and 6x, which is 10x quantity dx. Continue, we have 1/4 x minus 1/4 sine of 4x plus 1 over 6 sine 6x minus 1/2. We know that cosine of negative 2x is the same as cosine of positive 2x. And the integral of cosine 2x is 1/2 sine of 2x. Plus, the integral of cosine 10x is 1 over 10 sine of 10x plus c. So we have 1/4 the quantity of x minus 1/4 sine of 4x plus 1 over 6 sine of 6x minus 1/4 sine of 2x minus 1 over 20 sine of 10x plus c. Let me just rearrange and write the final answer as 1/4 quantity x minus 1/4 sine of 2x minus 1/4 sine of 4x plus 1 over 6 sine of 6x and minus 1 over 20 sine of 10x plus